Hello and welcome. In this lecture, we will start our journey into the world of monitoring multivariate industrial systems. In the introductory lectures of this course, we had remarked upon why we need multivariate SPM techniques. Let us refresh those concepts using this FCCU unit shown here. As we can see, there are several equipment or unit operations involved here, such as a reactor, distillation column, furnace, compressor, and etc. Now, if you are a process engineer responsible for this particular unit, you may be interested in knowing if this process as a whole is behaving normally or not. Or maybe you are interested in analyzing the operation of a single equipment. Maybe let's say this distillation column. In that case, the sensor signals around and inside the column will become part of your multivariate set. The first scenario is called plant-wide monitoring, where you're analyzing the whole plant as a single unit, while the latter scenario is called equipment level monitoring. Now, let us look at the different types of process that you may encounter. It is important to understand this because the same SPM technique will not provide satisfactory results for all the types of process. Therefore, it is important to understand the process that you are dealing with so that you can choose your SPM technique wisely. Now, there are four process types that have been shown here. The first one is the steady state process. In this process, your plant is operating at a steady state for most of the time. For example, let us consider this FCCU unit. Here, it is the incoming feed flow which to a large extent determines the state or the behavior of the variables in the rest of the plant. And so, if your feed remains stable most of the time, then your whole plant will operate steadily. The advantage of such a process is that the time does not enter into the modeling equation as a separate variable. And therefore, this makes the analysis and the task of building a multivariate solution very easy. On the other hand, if our feed flow is fluctuating or changing all the time, then our plant will be in transient state for a considerable period of time. And in that case, it will become very important to model this temporal behavior of the plant. For example, let's say we are writing a model for a temperature. Then we will have to write temperature as a function of not just feed flow, but also the time. While in the previous case here, we could have simply written temperature as a function of feed flow. Other type of process behavior that you can see are nonlinearity and clusters. Nonlinearity, as you may already understand, is said to be present if there are at least two variables that are related in a nonlinear way. Now, there are specialized techniques that have been developed or devised to handle these different types of processes. For example, if your process is a steady state process and linear, then PCA and PLS are your go-to tools for monitoring such process. On the other hand, if your process is a dynamic process, then a dynamic variant of PC and PLS can be employed. Or you could also use more specialized techniques such as CVA, which can model the dynamics in a more effective way. Similarly, for nonlinear and multimode processes, you can again employ PC and PLS with some modifications. You can see that PC and PLS are the base techniques whose variants can handle different types of processes. And therefore, we will focus on PC and PLS in the rest of this course. We will also briefly touch upon the modifications that would be required in PCA and PLS to be able to handle the different types of process that are shown here. That is the dynamic, nonlinear, and clustered processes. Specifically, these are the broad multivariate SPM related topics that we will cover in the coming lectures. Note that these techniques, the PC and PLS, and the tasks of fault detection and fault diagnosis that are listed here, these are not just some abstract techniques that are meant only for academic demonstrations. These are actually used in practice and have yielded successful results. Let us talk about a couple of publicly available examples. And these have been reported by Air Products, and DuPont. The first example comes from Air Products. I have already shared the links here, which you can use to access this publicly available material. So these first examples come from Air Product. Air Product, as you may already know, is one of the leading supplier of industrial gases. Let us look at what did they publish. So this is the article that has been published by them. Predictive analytics capture plant's heart rate. Here in this article, they mention about a process MD platform that they built to continuously monitor their process operations in real time. And here they have specifically mentioned the PLS and the PCA techniques that they used to build this process MD platform. Please feel free to go through this article. It's a very interesting article that showcases the industrial applications of these techniques. The other article that has been published by DuPont, here the authors have provided or shared with us their experience of using multivariate statistics for building process control and process monitoring solution. Here again, they have specifically talked about the PCA and PLS techniques that they used to build their solutions. Therefore, it is not for no reason that we can say that PCA and PLS is and should be your go-to tools for analyzing complex and multivariate industrial systems. And yes, even in the times of deep learning and chat GPTs. So, I will see you in the next lecture